Morning, all of you. This is sir. Hello,
Oh,
sir.
हेलो
Please start the webinar today.
ठीक है जो है
Sir.
so very good morning to today all the participants who are participating in this very seminar, all the scientists, director legal metrology, deputy directors from RRSLs and various institute, the controller and deputy controller, even inspectors from the different states, and the industry people who are participating in these very programs. The today topic is on design of blood glucose sensors, non-invasive blood glucose sensor devices. That design and it will be spoken by the Professor Rajbir Radvanshi. He is from Netaji Subhas University of Technology. So that is a very good topic and it is related with the day-to-day life of common people because the diabetes is very common in societies where you will find in every household some people are suffering from the diabetes and everybody is using some devices. So he will speak on those very things and that design and that its uses and all those type of things. So I request Professor Rajbir Redvanshi to start his lecture. श्री प्रोफेसर राजवीर यदुवंशी जी, प्लीज सर। हेलो प्रोफेसर राजवीर यदुवंशी सर। अतुल जी, राजवीर यदुवंशी जी कनेक्ट नहीं हो रहे हैं।
जी सर कनेक्ट है, मैं बात करता हूँ उससे मोबाइल के साथ, वो अभी हमसे
ओके
कनेक्ट है।
ओके ओके
Very good morning, sir. I think he's disconnected.
ओके सर।
Thank you, sir. Good morning, sir. Good morning.
मॉर्निंग, गुड मॉर्निंग।
Thank you, sir.
Hello, sir.
Yes, sir. Yes, sir.
Hello.
Yes, sir.
प्रोफेसर साहब कृपया अपना लेक्चर स्टार्ट करें।
हेलो।
आशुतोष जी, आवाज आ रही है मेरी?
हाँ आशुतोष जी, आपकी आवाज आ रही है प्रोफेसर साहब।
Sir, very good morning, sir.
अच्छा, गुड मॉर्निंग सर।
Good morning. Sir, kindly start your lecture, please, sir. Over to you.
जी जी जी
Thank you, sir. Thank you. Please.
Today we will be discussing a very burning problem as far as worldwide is concerned. I am Professor Rajveer Yadvanshi from Netaji Subhash University of Technology, Delhi. I'll be speaking on the topic of non-invasive blood glucose sensor design and implementation. In this topic, I'll be discussing the importance of this non-invasive blood glucose sensor. Reason being, there are somewhere 336 million people worldwide which are having problem of diabetes, or they are falling in that particular range. Diabetes is a disease, and mostly India is very much affected with this disease. The blood glucose level get increased to the normal limits, and then it creates lot of trouble to human being. The normal limits as far as HbA1c is concerned, it is 4 to 5.9 mm or 80 to 124 mg/dl. These are the units for measuring blood glucose levels. The reason for having this particular problem is that our pancreas, they release insulin, and then the insulin with this blood glucose molecule will supply energy to our cells, body cells or human body cells, which is not taking place, and then the sugar level is showing boosted or increased. This is basic reason why people are suffering from the blood glucose sugar enhanced level, and that is also known as diabetes. In short, we call it DM, diabetes mellitus. Now, I have made a comprehensive survey. As on date, I'll not hesitate to say that there is no instrument available worldwide which is FDA approved and can provide accurate, I again reiterate to use this word, accurate level of blood glucose with the method of non-invasive. Means there is no pricking required. Such instrument is not available worldwide which is FDA approved and accurate. I think 3-4 years back, even Apple, Samsung, they came up with a proposal that we have developed watch and which can give the non-invasive sugar levels or blood sugar glucose levels. But later on they withdrawn. Reason being, the accurate reading was not there and FDA did not approve. Now, as far as the sugar level measurement is concerned, at present either chemical or they take blood and then they estimate how much is the glucose level. So these techniques are known as vitro techniques. Vitro techniques means they take sample and based on permittivity, permeability and those combinations, they will determine how much is the glucose level in our body or in blood. Second method is Vito. And this Vito method is non-invasive, or by some mechanism, we get to know what is the sugar level or what is the blood glucose sugar level in real-time basis. So people worldwide making efforts so that the glucose level can be known without any pricking, because it is painful, as well as there may be chances that if we take blood samples, some infection may occur. A lot of companies are coming up with solutions with prick method, but it is really painful, as well as there are chances that there may be some sort of infection or some side effect on it. So my motive is that I want to make you aware that what word is presently doing, so that we can avoid this pricking method or invasive methods, take blood samples and then tell how much. And even if we presently see the Lal Path is doing same test, we give sample and then maybe tomorrow, day after tomorrow, they give report. But if we have some sort of electronic devices which can measure similar to what oximeter or the temperature IR meters are there, they are able to give you the the readings instantly or on real-time basis. So how we can do it? In my consecutive slides, you will see that there are various methods which will be in terms of electrical. Maybe they throw some frequency on the blood glucose molecule as per the wavelength of the molecules, and then that radio frequency is being absorbed in a particular volume, and based on that absorption we will be able to determine a real-time basis. Either it may be by shift in frequency, or it may be shift in amplitude, or it may be shift in phase. These shift in frequency, shift in magnitude, shift in frequency may occur by the molecule permeability or permittivity, which are electrical characteristics in nature. And based on those absorption coefficient or transmission coefficient, we may determine or calibrate in terms of sugar level. Maybe the permittivity or permeability change may affect the shift in frequency, and then that shift in frequency is being calibrated in terms of MGDL, that is sugar level. Or the theory of this came long back. There was a Beer-Lambert's law, and the Beer-Lambert's law spelled out this thing. Now you will see in these slides that
I'm sorry, your slides are not moving.
I have not moved yet.
Okay, thank you, sir. Thank you very
I'm
much.
giving only introduction. So you will see that these laws will be spelling out the absorbance behavior of the human tissue, and based on that the science has moved forward. We will see this mathematically, we will see experimentally, we will see this with all concepts. So my first slide will appear to you, this one. I'm not able to change my slide. Okay, now it's moved.
Yes, sir.
Now in this particular slide, you will see that we have shown some structures with different materials at some particular frequency, and then we will see the behavior maybe in micrometer. Now, if you see, we have composed different structures, and there we have used, if you see here, some sort of coal model which was already devised on phantom or human tissue or biological tissue, and then we'll see how the behavior of biological tissue is taking place with some set of frequencies. Now, if you see the first structure. This structure has been developed using different materials at terahertz wave. Then we have changed this. This was ultra wideband. We have changed the structure to the new structure, and it is narrowband structure, same at terahertz frequency. Then you will see here in this structure, we are showing the biological tissue, maybe nail, bone, blood, fat, skin at terahertz frequency. Then you will see in the next structure, again it is at terahertz frequency, but we have developed a cavity equal to finger size. And then we have seen in this particular structure that there is a 6-band structure. So we take the response of human tissue at different bands and then compose, and then we try to move towards some accurate readings. This is what the whole slide specs depicts. Now, in this whole slides, we have taken principle of Beer-Lambert's law, which says the absorbance will be equal to 3 different parameters, that is epsilon, C, and L. Here, the epsilon will be the molar extinction coefficient. Then C will be concentration, which we are figuring out to determine the concentration of blood sugar level. And L, the third parameter, L will spell out the path length. I will see in detail how these all, and then in total, we will be able to get the absorption. And then based on that absorption, we calibrated the blood sugar level, and we will be able to know this sugar level in real-time basis. And for this, we have targeted our either a wrist or a finger or earlobe. And in the wrist, we have seen there is a basilic vein which carry the bloods, and we target to radiate on this terahertz wave into a basilic wave, somewhere 2 mm at penetration depth, and then we get reflected wave as well as we get transmitted wave. And then based on those reflected wave and transmitted wave, we compute how much is the absorption, because the absorption is specific to the molecular wavelength of glucose, which has C6, H12, and O6. And in this glucose molecule, there are 2 covalent bonds. One is OH and another is CH. OH is similar to water, so we are not able to get that much reading in OH. So we like to target CH covalent bond and then create resonance. Based on that particular resonance, we create or find out the absorption coefficient, and then based on that absorption, we define the molar extinction coefficient, and then we predict that this is real time, the level of sugar in your basilic vein. As far as worldwide is concerned, these are the popular names. I have made a thorough search to determine that which country is working on what parameter and how much they are able to develop. So I got the topmost device, which is from Israel, and the company is Snoga. They are working on both already the invasive method. They are having sensors, but they are now targeting non-invasive so that they can launch. But again, the FDA is a hurdle. These devices will come into market only after approval of the FDA. Then only we'll say the device is accurate. So whenever we are going to market to search for this particular device, we need to reiterate, confirm that it is FDA approved. So this is a excellent information to the users who want to take the sensor device from the market. They should first ensure that the device which is available, maybe watch or maybe another device, you need to confirm that it is FDA approved. If it is FDA approved, then you can rely on. The second topmost company which is working in this domain is Diamond Tech, which is from German, and they are able to develop this device, but still the FDA approval is still they have to clear it. So before coming into the market, you go and take this Diamond Tech device, but you need to confirm that it is FDA approved. Then only you can rely that the device is suitable and it may provide accurate reading. Apple, it is working long back. The Apple came up with a solution in Apple Watch, and they quoted that our watch is able to determine the blood glucose level. Again, it was not able to clear FDA approval, and they rolled back this particular. Samsung, well known, so South Korea company, they were also coming up with the Galaxy watches, and they came up with these watches. Again, the FDA approval could not be awarded, and they rolled back this device. The present era, there is a earring. These earrings are based on radio frequency devices, and they have developed different size of rings. This is Moana Health. Excellent product, but again, the approval from FDA is still to be taken. And if it is possible, then you may sometime wear this particular ring, and then you will be able to, but it is radio frequency based. Glucotech, USA, they are also heavily working on this particular device, but still they are under research. Glucotrack is again another USA company. They are also working on the same target, but it is still in research. GlucoWise is an UK company. They are also trying to develop this particular device. Again, the product is not in the market. They are still trying to get the approval. Namura Medical, they have developed this. They say that sugar beet will be able to give you the real-time sugar level, but it is not yet approved by FDA. Abbott is well-known company as far as medical devices is concerned, but they have been successfully able to develop a device, but only with minimum invasive, maybe pricking or some other device, but not the total non-invasive method. Dexcom is another company which has also developed a product, but only with minimally invasive method. So these are the worldwide survey which I have carried out on real-time base on for real-time non-invasive glucose monitoring device. As I said, the basic principle of working of all non-invasive blood glucose sensors, mostly if you use radio frequency, they are based on similar to Doppler effect, and we carry out frequency shift. The frequency shift we calibrate in terms of sugar level, and then we can predict. The second is the amplitude shift. We take reflected signal or transmitted signal, and then try to see how much is the shift in amplitude, and then shift in amplitude which is being calibrated to determine how much is the sugar level. Third is phase shift. Phase shift is another feature by which we will be able to get. So the phase shift will give me the angle, how much the angle shift is there, and then we calibrate similarly. And then, but to get all these parameters, there are different compositions, either capacitance, conductivity, resistance, inductance, dielectric, then index, not many parameters we take, so that we get these above 3 parameters. And sometime you may get like some snow guys there. They may be taking all 3 and then reporting, so that you get accurate reading. The methods to get these parameters are popular, maybe near infrared spectroscopy, short wave infrared spectroscopy, radio frequency and microwave imaging, eye scans. So these are the popular methods which are being used to work towards developing the non-invasive sensor. This diagram has been developed by me, and we are trying to develop our sensor based on this particular principle. Here I have shown the palm or wrist, and in this wrist we are transmitting a terahertz wave, as I have shown you already the structure. And from this terahertz wave, we are targeting the wavelength of blood glucose molecules. And then the amount of the blood glucose molecules, they are somewhere 1 nanometer wavelength. They will be creating some sort of absorbance, and that absorbance is being measured either with the reflected beam or with the transmitted beam. That's what we use somewhere 1600 nanometer and 1700, in between 1600 nanometer and 1700 nanometer as a wavelength specific, which we got from the research that the wavelength of the blood glucose molecule correspond in this particular range. So that we create resonance, and from this resonance we create absorbance phenomena, and from this absorbance phenomena we compute the blood sugar level, or say blood concentration. Now to build a device, this is a block diagram we have developed. We have used 3 volt pencil cell. Then we have also integrated some ML model. So 0.5 to 0.7 watt of output power we have tried to use. And the frequencies again 1600 nanometer to 1700 nanometer. Here is a LED, then the finger chamber, the photodiode. Then the photodiode will give us the current, but this signal is very less. We tried to amplify it, and from the amplifier we tried to built in a Bluetooth antenna, which Bluetooth antenna will be able to transmit the readings obtained to a mobile app. We have also developed a mobile app so that we can see the readings in text format as well as in graphical format. So basic concept of the sensor which is operating in this particular domain. Now, this is the complete flow diagram which will spell out each bit how the device can be developed. So there is a sensing element. Again, the sensing element will have a finger chamber similar to oximeter. That will have a 600 nanometer LED. It will have a 16 similar what LED is transmitting will have same wavelength photodetector. It will go, the received signal is very less. It will go to amplification, and then from the amplified signal, it will go to signal processing. The signal processing will tell us the absorbance, and the absorbance will get calibrated to the unit we want to display in either maybe mm or maybe in MGDL. So absorbance is being calibrated to MGDL as shown in this particular block diagram. Then the sensor acquired data is being represented, and the microcontroller has been inbuilt with the integrated of ML model. We have developed ML model also for this. The ML model will stop us for any erratic reading. So the ML model will take care that you do not get any erratic reading, because the database will acquire a lot of data. Already it has what will be your blood glucose score level. It will compare, and if there is some erratic data, it will stop you to get that particular, and you get factual data. And through Bluetooth model, the app will be connected. You can see the display of your real-time monitoring device in this display unit, as well as it will route the data acquired to mobile app. This is whole flow philosophy of the blood glucose sensor. Then we have developed a similar sort of sensor at microwave frequency also. Microwave frequency was somewhere at below 10 gigahertz. So we tested similar sort of test with this device, and we carried out the device hardware measurement. Then again, the same device which I am showing the block diagram, same whatever we have discussed previously is being depicted here. This is the sensor circuit diagram, same, but here I am showing with the components. Now, after we carried out testing, so here if you see this table, this is analog voltage, and then we calibrate it to corresponding NGDL. Now, this is another hardware we have developed to see the readings. Now, after we carried out these readings, we carried out a comparative analysis of how much is the accuracy we are able to get with invasive methods and non-invasive methods. Right now, I'll not be able to give you the exact reading. We are still working on this so that we try to get the equivalent invasive as well as non-invasive. So it will take a lot of time to get you the accurate reading. Now, during these developments, these are the few important parameters which we need to look into. One is sensitivity, figure of merit, the quality factor, the signal to noise ratio, the selectivity, one more parameter, detection limit. These are the few important parameters which you need to work on while developing a non-invasive blood glucose sensor. Now, while developing either microwave or optical or terahertz sensor, there are few important parameters we need to consider. I have highlighted these parameters. Maybe microwave, terahertz, the both frequencies, both spectrum can be used to develop these biosensors. Biosensors integration with mobile help, definitely it will give you the remote connectivity and remote monitoring. Biosensor for remote monitoring as well as telemedicine. Yeah, this is very important. Cole model and DB model, these are the two different mathematical models available to biotechnologists and the mathematicians. They can mimic the human tissue with some electrical characteristics. We have done the same thing. We have developed a phantom, and from phantom we have extracted the different values based on both models. And now today I can conclude that we developed the biological tissue with DB model as well as Cole model, but the accurate model found to be Cole as compared to DB model. Biosensor as IoT device, integrated AI platforms. In ML model, the advantage which we have other than the accuracy or error removal, it can predict, it can provide alerts, it can provide suggestions, it can provide recommendations on food habits and the meditations as well as exercises. The person who is having the sensor with the ML model will be informed based on customized solutions. So that is the advantage of developing or integrating the sensor with ML model. IoT device as biosensor integrated with Bluetooth enabled features can upload data on the cloud, and if the data is sufficiently large, the predictions becomes very easy, and based on those predictions, the lifestyle and other features can be altered so that the person can avoid this disease or sugar or blood sugar enhancement. The data can be stored and uploaded on the cloud, as I already told you. And the app we have developed for Android as well as iOS compatible solutions, so that even the Apple customer as well as Android customers are able to take the app applications as individually. Then customized advisory on food intake, exercise and medications can be imparted. Health status of some important organs such as pancreas, gallbladder, and small intestine can also be integrated into this mobile app. The mobile app displaying text, graph, and other digital informations. So it becomes handy to the person who is using this particular sensor. Compute error. This is very important feature which we were able to get from the ML model. Reason being, if the sensor is not connected or the chamber finger is not making proper contact, so the instant reading of the sensor may be erratic. So if you integrate with ML model, that erratic reading is instantly reported. So that now with the ML model, the individual or the person who is using this particular sensor is informed that your finger is not placed properly, or there is some settings are required, so that the reading becomes accurate to the person measuring or using this particular device. From this, these are the blood glucose molecules. We are sending terahertz signal from the meter, and each molecule at this particular frequency will create resonance, and from that resonance or oscillations, the absorbance will increase or decrease depending on the number of molecules in that particular volume. And then the detection current will vary, and the detection current is calibrated with equivalent sugar level or blood glucose level, and from signal processing, this is reported on real time, maybe in display, or maybe sent to cloud for ML model data acquisition system, so that the individual report is being created, maybe monthly, maybe yearly, maybe quarterly. So depending on that, your database will get generated and the ML model will become more and more strong. Now, the role of a mobile app for the sensor. The mobile app will have the features to transmit text to mobile app while Bluetooth from the sensor. Here, the library Flutter and React Native is compatible for iOS as well as Android. The blood concentration or sugar level in MGDL relationship is purely based on Beer-Lambert law, which tells about the absorption. The absorption, as per as Beer-Lambert's law, will be depending on molar extinction coefficient, molar concentration, and transmission length of the signal. The recommendation, alert system, food habit, exercises are being available in the mobile app. Health category classification will also be available and in customized, depending on the customized solutions. IoT connected with cloud for data acquisition. Sensor illumination, this is absolutely important point which we observed during development. Now, these are few hardware measurements on microwave device which we have developed. So these are the parameters maybe in S11. Now, this, as I already said, that in this parameter, I feel both the one is shift in frequency and other is shift in magnitude. So with these both components, I'll be able to say how much is the glucose concentration. So a mapping is being provided based on shift in frequency and based on magnitude of the signal received or transmitted. Same, the previous graph is being depicted in this pattern. Now, there are possibilities that the terahertz sensors can be developed at different frequencies, and then you make a composite signal, and that composite signal may be acquired. Not only this, this is a terahertz. We may integrate ultrasonic sensors into this particular reading, and then take the input of both ultrasonic and terahertz sensor, and then predict the accurate results. There are some techniques which are not only taking terahertz frequency, ultrasonic frequency, in a combination of that, they are taking some scanning. So imaging also, and then imaging result, ultrasonic result, and terahertz frequency result, they make a composite signal, and then it becomes more accurate but complex. Now again, this is what we have already seen. Basic development technique is again based on blood circulation. We are all aware that the blood circulate one in forward frequency. Now, if you see here, this is the structure. Now, this structure will have some cavity or finger housing. The finger housing have different compositions of nail, bone, blood, fat, skin, etc. These nail, bone, blood, fat, skin have some electrical parameters, and these electrical parameters are being placed in finger chamber, and then the input signal is being applied, maybe either to monitor in reflected mode or to monitor in transmitted mode is being depicted here. And this particular method is most popularly known as cold model. So here we are basically representing a biological tissue with mathematical formulations to get you the exact behavior of your finger tissue, how the finger tissue will behave at particular frequency. So these are the responses we have noted down. We have taken frequency of 170 to 190 terahertz, and using this cold model, now these are being the readings being reported from 50 mg to 250 mg DL. This is again the depiction of the cold model which we have developed. Now, which I was talking about, the mathematical relation of cold model. Here A is absorption, epsilon, C and L, which I have already told you, and the method of absorption is broadly depicted on this cold model equation. This is the hardware development of blood glucose sensor. Here, this shows the finger housing. In this finger housing, all these the photodiode, the LED, these are being placed here. Now, if we go more deeper into the absorptions of the sensor, here we have taken this particular working of the device based on interference theory, and then computed the absorption. Now, to compute these absorptions using software, we have taken help of CST software, in which we devised a flinked port to carry out the analysis of the biological tissue. This is the detailed analysis that we have taken this particular absorber at terahertz, which is between 1600 nanometer to 1700 nanometer, and we have so that we can create resonance, we have taken the structure at a wavelength of λ/4, so that the absorption theory can be well explained. So we devised this particular flanked port so that we can carry out the real-time analysis of cold model. This is the mathematics behind this, because the total interference theory will be applied so that we get the exact absorption by these blood glucose molecules. Here, not only the transmission and reflection coefficient, but the incidence angle and reflected angle will also contribute, which is being depicted by this particular equation. Now, to create these environments, we need to understand the theory of absorbers at terahertz frequency. The theory of developing these absorbers at terahertz frequency will obey some sort of metamaterial characteristics. And these metamaterial characteristics are depending on negative permittivity and negative permeability. It means it will not follow Snell's law. The material which are required to develop these type of absorbers will not follow Snell's law. They are modified, and these materials will not be available in nature. We need to create them. We need to modify the reflected coefficients, and then only we can realize the absorbers at terahertz frequency. So the main parameter, if you see here, we have worked on epsilon negative materials. So 1 to 2nd quadrant is there. Then 3rd quadrant, we have the double negative material. We have taken 2nd and 3rd quadrant help so that we can devise our absorbers. The absorber, these are the few important parameters he like to mention. The impedance matching, this is crucial parameter. We need to create that it should match to 377 ohm impedance. It should have negative refractiveness. It should have TM polarization, so that we want to create the device. It should not more depend on the incidence angle. So we try to neutralize the angle dependency so that it can be made angle insensitive. So TE and TM polarization. Here the loop currents formations, magnetic field generation, and then only the absorption takes place. So now to get these absorption parameter as far as accurate is concerned, we need to make this device polarization sensitive, as well as sometimes it is polarization insensitive. Incidence angle is to be taken care of, or sometimes you need to devise your device in such a way that it should not depend on incidence angle. So these are the theory behind developing the absorber so that we can use these absorbers at equivalence to blood glucose concentration level. Now, those people, because the device I have shown you is either with the help of antenna or either with the help of absorber, but both phenomena are entirely different. We can devise a sensor using antenna. We can devise the similar sensor using absorber. So if you see here, the left side window will tell you what are the basic fundamentals of absorber, and the right side window will let you know that if you want to devise a blood glucose sensor using antenna, so theory is entirely different. Size of absorber in here, if you see here, is lambda by 4. If you see here, the size of the antenna will not depend on lambda by 4, it will be lambda by 2. The impedance matching here is 377, impedance matching here is 50 ohm. The material here is DNG or single negative, but here the material is perfectly positive. But you see here we devise flanked port, here we devise the waveguide, nano waveguide. Here we have resonant circuit, here also we have resonant circuit. Here there is no dipole creation, but here in antenna theory we have to create dipoles. So they are totally different structure and different philosophy, different science to devise antenna as well as absorber. Now, if we work on absorber to design our sensor, this theory will apply. I'll not go through this. Those who are more interested can take this slide and refer. Now, these are the important parameters for absorber. You need to deal with reflection coefficient. You need to deal with absorption. You need to deal with incidence angle. You need to deal with polarization angle. We need to deal with impedance. We need to deal with bandwidth. We need to, this is very crucial and very important parameter, resonant modes. These modes are frequency specific, and they can tell you what will be the resultant fields. So the resonant modes is applicable in both the phenomena, maybe in absorption as well as on antenna theory. The structures which we have developed can be realized with RLC circuits, with surface currents, with electric and magnetic fields. We take all these parameters and then say that now our device is ready for integrating into the sensor. This is another structure we have depicted. So the structure is basically built with resonant circuit placed on top, the substrate and the ground plane. This is basic concept of the structure of absorber at terahertz frequency. Only the thing is that the substrate material will get changed. The FSS frequency specific structure, the structure may get changed. Material also may get changed. Sometimes we may use gold, sometimes we may use alumina, sometimes we may use copper, sometimes we may use silver. Similarly, the for ground plane and the substrate. These are all frequency specific. Now, this is one structure where dimensions are in micrometer. So here, this is different structure where the feed is different. We have used Gaussian beam and silver nanowave guide to develop these structures. This is theory behind the structure, that we need to create the input impedance to the free space impedance, which is 377 ohm. This is the theory of metamaterial. Here, if you'll see that the red is the incident wave. So depending on behavior of the material, generally characteristics is this. So this is positive. If you see the relationship of fourth quadrant, where all antenna theory operates. Now here, if you see, this is the general behavior of the signal in material, but we have altered it. So the materials are man-made materials. Because of those material characterization, we have termed this as negative reflection or metamaterial. So artificially generated materials are known as negative reflection coefficient material or metamaterials. So here the Snell's law is being modified. The structure, same structure with different configurations, and different configuration for same spectrum is being depicted here. Now, these to develop that particular device at terahertz blood glucose sensor, there are different steps involved while devising the devices. So this is first structure, second structure, third structure, fourth structure, fifth structure. These developing structure with different stages is being depicted here. Now, to see the behavior of absorbance, we are able to see them with the help of fields, T fields, TM fields. Now, these are the behaviors depending on the structure and the material we are able to get response. One is frequency and reflections, another is frequency versus absorbance. This is what we are targeting. If you see here absorbance, so at particular frequency, we like to tune these behaviors very sharp. Now, if you see on the top graph, there is a shift in frequency here. So we are targeting here shift in frequency. Here we are targeting about the absorption. And these targeting shift in frequency, targeting absorption behavior is in designer hand. So designer can alter any of the parameter, which is being required to develop a terahertz blood glucose sensor. Now, the sensor characteristics has been identified using the combination of E fields and H fields. Basically, the E field and H field, I was emphasizing on resonant modes. So here we can determine the mode configuration of our sensor. Again, the frequency versus absorption. Now here, frequency versus absorption. Now, more explanation as far as pole model is concerned. Here you find that these are the electrical parameters and these are the biological tissue parameters. So biological tissue parameters have been modeled in electrical parameters. This is the dimensions of our proposed device. These are the surveys already available in the literature, which people have developed or working on this. These are the H fields. These are again the absorption presented in these different configurations. These are the structures developed for behaving on particle frequency. Now again, we can see depending on the refractive index, there is a change shift in frequency is being depicted with this particular graph. Here we can see the response of the structure depending on the value of permittivity of the material, which will have different as far as concentration of blood glucose parameter. Again, now these are the parameters which we need to know while developing a terahertz sensor. And the important parameters is the frequency in terahertz, figure of merit, sensitivity, detection limit, dynamic range, signal to noise ratio, and spatial resolution. So these are the parameters. Some we have computed based on healthy. The concentration level will be different. And based on those concentration level, we have characterized our sensor on these parameters, quality factor, figure of merit, detection limit, and many more. These are the fields while we carry out on absorbers. Again, these are this Z11 is very important parameters because we have to develop these sensors to 377 ohm, that is free space zone. Again, we have developed another sensor or different frequency, but the concept remains same. I'll be showing you a very fast mode now because time is limited. This is flow chart. This is the structure. This is the absorbs behavior, linear fate. For this particular basic theory of absorber is this. So we tried to get S21 as equal to 0 so that we get good relationship between the absorption and reflection coefficient. This is how we try to match our impedance of the sensor. This is the theory of getting 377 ohm impedance. These are the basic design to get simplification approach for impedance matching. This is exact theory which we develop so that we get 377 ohm impedance of our sensor. This is what the dimension table tells us to develop. But here we have used different materials, VO2, SiO2, and gold. In other sensor, we have used different materials. So these are the responses being presented here. This is electrical equivalent circuit. We can realize the structure with this RLC equivalent circuit so that we report the behavior of sensor and compare the behavior of that sensor with our mathematical model, which is equivalent to the combination of RLC circuit. So these are the value of components. Now, in my conclusion, I'll say that Snoga, Diamond Tech, there is a China company, SI Bio, Dexcom, Apple, Abbott, Samsung, Mavano, they all are working. And I think in fine day, we will be able to get the device developed. Very limited Indian people are working in this domain. So I'll request, because this is crucial uh, crucial and very important parameter which everyone need to know. Even the healthy people, they want to know, but they should not be exposed to the invasive method where every time the individual has to either with pricking or with the needle take the sample out, and then only they should be able to know. But that is why people who are having research acumen should work in this particular domain and eradicate the problem of measuring. And not only with measuring, we can even give a little bit predictions so that the people take care of their health and become fit. I'll be showing few images, which this is one by which the device can look like this. Then this is one, this is second, this third, this fourth. So this shape will definitely help and eradicate the problem of not only India, worldwide. So from this particular lecture, I'll try to motivate people working in this domain that more and more research is required so that we can overcome the problem of pricking and problem of taking samples so that we can avoid the infections and the pain which people are bearing worldwide right now. With this, I conclude my today's lecture. If any questions are there, most welcome.
Thank you, sir, for this brief and wonderful presentation. Actually, as you have already spoken, it is very important in today's scenario. Basically, this non-invasive method is important, and we certainly need something which can happen with the help of you people, your scientists who are working in all these fields. Thank you very much, sir.
Thank you, sir.
Thank you. Atulji, can we take
Yes, sir.
Dr. Professor Rajveer Yadvanshi, sir, who is working as a professor in National Subhash Chandra Institute of Technology in Delhi, Netaji Subhash Institute of Technology. He has done a lot of research work. He is a PhD from Delhi University, and he has actually supported, guided more than 10 students for the PhD. He is doing more than 40 postgraduate students. He is supporting. He has done a lot of other research and technical works, a lot of research patents, etc., wherein he has worked. And today's topic, as we are all aware, it was very important considering our requirement of time, because as when we use our needle for taking the blood for measurement of blood sugar is very difficult, and it is very painful also. So I would like to thank Professor Yadvanshi, sir. Sir, we will put this video on the platform, on our platform, as well as in social media platforms. And I would like to request you to kindly share me your PPT so that we can place it on our website, on our portal, where the participants can see at any point of time.
Okay, sir. Thank you. I'll share it. No problem.
Thank you very much, sir. Thank you very much. And what you people are doing in India, kindly let us know whether you people are also working in this field to develop this technology in India.
You are asking me?
Yes, sir. Yes, sir.
Yes, sir. We are working on this.
Very good. Sir, if you can work, so you can think of it. We can also work together for this development.
Not only you, sir, I welcome any audience to join me in this particular era.
Thank you very
So
much.
that
Because
we
sir,
can provide Indian solution to the mass.
because basically legal methodology is concerned about this blood pressure meter instrument and the thermometer testing equipment. We are already working in it, but all these are at the old technology. And if we can work with the help of industry, certainly we know large number of industries who are developing these technology, not actually this particular technology, by which without doing any type of pinching, we can we can calculate or we can observe, we can find the blood pressure, sorry, the sugar level in the blood of a human. Can certainly work on it. It is a very good thing if we can think of it.
Okay, sir. Thank you.
Yes, sir. Thank you.
Okay,
I would like
sir.
to thank
you.
all
I
the
exit now.
participants. Thank you very much, sir. Kindly share me your PPT, sir.
Yeah,
I
yeah,
would like
sure, sir.
all the participants, our guest, Shri B.N. Dixit, Director. Sir, thank you very much for your kind and motivating words. We will meet next week with the next topic. Thank you very much.